Hello, happy Tuesday. So what we're going to do today is talk about, we kind of looked at what a proportional relationship is yesterday, right? It really just means, are they the same or are they not? Well, there's different ways I can show you proportions. And I kind of dropped that hint when we started talking about it yesterday. There's going to be tables, equations, graphs, and how does a table for an equation look like as a table, or excuse me, how does an equation look like as a table? What does it look like as a graph? How do we go back and forth between all of these things? So this is to the first glimpse, I guess, of a proportional table. So we really approach it the same way as we do a situation. Ooh, hey, I like this over here. Let me move it. Frozen. Hold on, got to reshare. Sorry. I like to look at what I'm talking about. There we go. All right. So I have some examples of proportional tables and I have some examples of non-proportional tables. And I really want to spend a lot of time on at least one of each, showing you how you could tell me it is or is not proportional. So remember, if it's proportional, we are looking for things to be the same, right? In this case, it's about the pounds of apples and the cost of apples. So one way, a surefire way to do this is to make a ratio for each of these. And that's going to be my first strategy. We're going to put cost over the number of pounds of apples. Okay, I'm going to literally take column 2, cost, and put it over apples. Okay, the dollars per pound is essentially what I would be finding if I was looking at the unit rate. I'm even going to write that, dollars per pound. Okay, so I'm going to set up each one. I'm going to take 8 over 2, 12 over 3, 16 over 4, and 20 over 5. Now these numbers are pretty nice and small. I really don't have to even grab my calculator for that. I'm going to go ahead and divide. So 8 by 2 is 4. 12 divided by 3 is 4. 16 divided by 4. And 20 divided by 5. Did I say 25? Anyways, they're all 4. All have a unit rate of $4 per pound, confirming that it is proportional, right? We already knew that from the start. It's just how can we support that, okay? So let's do some color coordinating here. We put cost over, let's do blue since we had that blue apple conversation the other day. Blue apples. We do that too, like that. Okay, beautiful. So making that unit rate, again, you just have to do it in this case 4 times to prove that it is or is not the same. If you wanted to use a common multiplier for something like this, check this out. So whenever you try to find a common multiplier, you're always looking for a pair of numbers that stands out to you, right? Like, oh, I know. So like when I see 2 and 8, my brain's going ding, 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 times 4, right? Maybe your brain did that with some other numbers on here and follow that, go with that strategy because I see pounds times 4 got me the cost. That's also true for this row and this row and this row. So guys, if I gave you a worksheet or a proportional table and asked, is it proportional? Or if I gave you a table and said, is it proportional or not? You could show me that and that would be enough justification. And all of them have that same increase of multiplying by 4, right? It's a common multiplier. You can also find common multipliers up and down. Okay, watch this. So I can do 2 times 2 gets me 4. 8 times 2 also got me 16, right? That's a common multiplier that they share. Not as easy going to 3 and 12, but you can find that value. Here, I'll go from 3 to 5. Okay. 5 divided by 3 is 1.6 repeating. Write that really quick, different color. 1.6 repeating is the multiplication factor. So now I'm going to take that number, 1.6 repeating, and I'm just going to hit times 12. And hopefully, ta-da, we get 20. That is the same over here. Confirming that common multiplier. There's, again, I could relate 2 to 3, 2 to 4, and 2 to 5 if I wanted to. Your job is to prove in one of these ways that they all match each other. Again, remember, we're on the proportional table side, okay? I'm going to show you these bottom two examples. Or actually, how about, I'm going to go ahead and do this one with you guys just because it's nasty numbers. I'm going to leave one on the non-proportional side for you to do on your own, okay? All right, so for this one, I'm going to go ahead and do miles over gallon, miles per gallon. 45.5 over 2, 68 1/4 over 3, 113 7/500 over 5, 182 over 8. So this is a perfect example of like, man, I don't see one pretty multiplier in any direction. So I'm really going to utilize this unit rate method. Miles divided by gallons. So I have 22.5 for that first one. 68 1/4. Sorry. Divided by 3. Oh, I did not. Oh, I did put 1/4. They're supposed to be the same. Whoops. Oh, this can't be right. I must type that in wrong. Hold on, 45.5. I don't think I typed in the half. There we go. All right, that makes me feel better. I want to record that stuff out or edit that stuff out so bad. I can't. It's okay. All right. So keep going. 113.75. Another 22. 7/500. And my whole numbers for last. Beautiful. Ta-da. All equal. All proportional tables. Check. Okay. Now you can see I even did a little typo in the calculator just now. So if you're one of those kids, you find you're making mistakes a lot with your fingers, you're typing it in, just always double check your work, okay? Or slow down. That was my issue. All right, so non-proportional tables. We're going to do the same thing, same strategies, but this time we should prove that they aren't the same unit rate or don't have the common multiplier. Right away, I see one. I see 2 and a 4. My brain goes right there. That's doubled times 2. But 20 times 2 is not 80. That would not be true. Okay. Another one that I noticed. 2 times 10 gets me 20. 3 times 10 is not 50, right? That is not, I'm sorry, that's really great. That is not a common multiplier in that table, okay? Now I'm going to prove it with the unit rates just because that's my favorite. I think that will end up being yours too. It's go to every time, no matter how nasty the numbers get. Remember on this example, the numbers got pretty gross and all of a sudden that common multiplier method wasn't very good for me. It would take a long time. So having that backup plan is really good. Let's do the number of apples per tree. That's essentially what we're finding, right? All right, so let's do this. Apples per tree, apples per tree, apples per tree, apples per tree. All right, so 20 divided by 2, I know is 10. 80 divided by 4, I know is 20. This one's 22. And the only gross one, 16.6 repeating. So not only are they not proportional, but every single one is different than each other. And I really wish I, hadn't done all of them different, because I want you to be aware there can be two that match in a table. But if I put another one in, it doesn't. It's all or nothing. Okay. So no matter what, make sure you check all the different spots in that table. Okay. So again, this is our non-proportional side. What I'd like you to do is focus on this table here and see if you can find any way of the ones we talked about to tell me or prove that it is not proportional. How could you convince somebody else that it's not proportional? That's how I want you to approach it. You may want to freeze it here. I'm going to unshare. Maybe. All right. See you guys in a minute.